What's up, fam squad? Back at it again. It's May 18th, 10:12 p.m. Didn't do a whole lot today, to be honest. It was pretty chill. And finished, let's see. Build a modern computer. I am on module 5. I finished the ALU yesterday, as you can see, and finished these two lectures today. Memory units I'm still working on. And the flip-flop gate, I don't really understand. Like the clock concept, I get it. It's like an oscillator, right? Right? 1 0 1 0. And then the flip-flop is to store the previous bit, right? Is that what it's like the purpose of flip-flop gate? Flip and flop. Storing, right? Storing a single bit of binary data. And then if the set bit is on, then you can set it, and then if the reset bit is on, then you uh make it flip back. And then they cannot both be on, right? Then that represents an invalid state because you cannot set and reset at the same time, which gives rise to the JK gate. If I'm not mistaken, I still have to like solidify these concepts. Yeah. Maintain a specific state until a new input changes it, right? So yeah, so it stores a certain thing, right? JK, right? Um, right. So yeah, this one I still don't quite get. I want to sketch this out and then really understand, like trace out how it really works. So I know these are the NAND gates. These are the NAND gates as well, and then this is the clock, and then it basically acts as an enabler, right? I think. Um, yeah, this video was very informative. So it starts off with the normal SR flip-flop, and then uh you feed the clock into this as well, and then and then that becomes a gated flip-flop, and then ultimately it becomes the one just now, which is this, I think JK flip-flop. T flip-flop, I don't even know. Yeah, but that so yeah, I need to trace this out. But this is pretty interesting though, like learning about transistors, how they are super duper small, like 5 2 nanometers, kind of small. Um, Fascinating stuff. And then yeah, yeah, pretty interesting. And then and then also another resource that helped a lot was the crash course computer science um thing. Crash course computer science. This helped a lot, to be honest. This, and I'm on episode 6, I think. What the fuck? It's on 38 now? Jesus. In the future. And this was 7 years ago. This would be pretty interesting. But I'm on what am I on right now? I'm on level 6, I believe. Binary after binary. This one I've done. Yeah, so I'm on 6 and 7. This course teaches 7 before RAM. Because we're talking about clock speed and everything. So that's pretty interesting. I don't.
one, one bit, and the 8-bit value is now saved in them. Definitely puts zero. Add like I did again.
Yeah, the latch and shit. It's like, yeah. So, anyways, let's do lead code. I'm not gonna do this because it's hard. Okay, let's see. Let's check it out. Let's check it out. It's 75% success rate. So let's see. You were given. two integers m and n. Consider an m and n grid where each cell is initially white. So there are three cells? Right, okay. Sure. Okay. I'm not gonna do this. Um, let's do something else. Um, I don't know. What do we want to do here? What do we want to do here? I want to continue on the lectures, if I'm being honest. So I think I'm just gonna do some chill. Um, what about okay, close my eyes. Uh, yep, okay, let's load a bit more. Okay, close my eyes. And then we'll pick one that's like here. And then if this is not 60% acceptance or higher, then I'll choose the closest one that is, right? Okay. Oh, oops. Okay, right there. Boom. 55. Uh, sure. Let's try this, and then sum of left leaves this one. Fizz Buzz. I mean, Fizz Buzz is just a classic one. Oh, fuck. That's so nice. Yeah, I'm also still extremely sick, guys. Um, yeah, it is what it is. Oh, Fizzbiz. All right. There should be a vector of string called res for auto number in n if n divided by 3 equals 0 and n modular 5 is 0, then the res dot push back. You want to push back is bus, right? Else if this is 0, and what you want to push is fizz, right? Else, right? Don't know if this will work. I don't think this will work. String in integer to string C++. String. Yeah, this one, something like that. Oh, oops. Here. Um, oh, oops. For Why? Oh, oops. One index. So this would be one. Yeah, I wasn't reading the question. The classic fizz biz is not like this. So I'm sure there are easier ways. Um, yeah, okay, I'm not gonna check this out. Okay, this one I've never done before, so this will be pretty interesting. Given a string S, which consists of lowercase or uppercase letters, return the length of the longest palindrome that can be built with those letters. Letters are case sensitive. For example, AA is not considered a palindrome. CC, CCDDCC, DCCACCD. Okay, interesting. Longest palindrome that could be built. Um, all right, so I'm thinking something about frequencies, right? Let's try this one. I want to do something that's not right. Given the root of a binary tree, return the sum of all left leaves. Okay, and for result equals to 0, right? Okay. Root equals a null pointer. What I want to do is return result, right? So it will return 0. The base case. If not, then I'll go into the left, right? Go to the left. Then I'll go into the left. It's not. To the left, turn res. I feel like something like that. So res equals 0 here, right? I call it. If it's equals to pointer, it will return 0. It's not. I go here. I feel like I don't even need this. Because if I detect a root node, oh, but let's say if I don't have these, right? Interesting. This function should only walk to the left side of the tree. Hmm. I know this is wrong, but some of left leaves. No, it should be if something. If if the left came back as false, then I will add the value into the thing. If it came back true, no, it doesn't make any sense. I don't know how to do this. Mm-hmm. Mm-hmm. Let's see. So what I want to do here. Yeah, there has to be some sort of flag, right? I believe. Symbol DF is trick. Like this one, I kind of understand. Okay, so you're writing a helper function, and then tree node root, and sum, you pass it by reference, and then is left. And then if root left equals to null, and root right equals to null, and then if, somehow just do and is left, then what you want to do is sum plus or equals to root value because it is left and return. And then else, if root left is a thing, then I want to call into it. If root right, then I want to call into it. Okay, that's it. Sure. That makes a lot of sense to me. And then what I want to do here is if root is if root is null, then I want to return 0, right? And then I want to helper root sum. This one makes a lot of sense to me. Like, but I couldn't write it myself. That's the like problem, right? Like it's not difficult at all now that I see the solution. It's just I couldn't come up with this, bro, with my brain. Tragic. Okay, well, that was pretty interesting. This one, it's for sure something about the frequency. 100%. It's something about like using a map and then adding frequencies. And then if the frequency is divisible by 2, then you reduce it. And then if it's all ones, then you just plus 1. Um, I think it's something along those lines. Um, do I want to do this now? I have a general solution in my mind, but do I want to code it out? Okay, sure, whatever. Okay, so for uh I don't know why I just don't feel like for stuff. And what we want to do here is while frequency, no, while iterator second is no is larger than 1. Is it larger than 1? So it can't be 0. It could be 0 after you decrement it. Um, but let's say the possible values are 0 to infinity, right? 0 to 10,000. You just want to keep subtracting 2, subtracting 2, subtracting 2, subtracting 2. Um, and if it starts with a 1, then you don't really want to. you don't really want to do any of that shit because it doesn't help, right? So let's say if it's bigger than one. So you start with two, right? So you start with two. So frequency of character is at least two, right? So what you want to do is is you want to minus this, right? And then here is in res, and then res plus or equals to two, right? Until every single one is one. And then for, again, you iterate through the list. If iterator second equals to greater than one, then you return res plus one. Else, return res. Because here, theoretically, all of the iterators should be one or zero, right? And they're all different characters. And the only character that can fit is the one that's within, right? That's an odd number. So yeah, so imagine it's this, then you would have A equals to 1, B equals to 1, C equals to 4, D equals to 2, right? Then here, for A equals to 1, for A equals to 1, A to the second is not bigger than 1, so it'll just go to the next. And then B, it go to the next. And then C, it'll minus 2. And then it will be 2, so res will plus 2, so it will be 2. And then C would minus 2 again. And then res will plus 2 again, so it's 4. And then it will be smaller than 1. Uh, it's not bigger than 1, so it goes to the next. So it's D, and then you minus 2. And then here, everything will be 1s. No, if equals to 1. Yep, something like that, I believe. 9. Yeah, let's not do iterator then. For this should work, I think. It's just not always minus minus, and that's not how it works. Yeah, this should work. Okay, yeah, beautiful. Beautiful. I wonder if there is a better way to do this. Um, I just ran it 3 times. I don't know. I don't know if my solution is that good, but it beats 100% time. There's a memory, it's not doing that bad. Um, so I'm just gonna call it. Yeah, this one I actually did myself. The other one, DFS one, oh my God, I'm thinking about the Dijkstra's shit. Like, damn, that shit is tough. Sorry. Yeah, but yeah, I mean, leak code part of today is complete. Um, this shit is, I don't even know, bro. I really want to get my order book project started. Not sure how to start that one, to be honest. It just seems like such a difficult project. Like it's just a lot of lines of code. I do want to do this though. So I'm thinking if I can find a um implementation like walkthrough, WK, what was the guy's name? WK South. How do I even go about doing this? Is my question. How do I even go about this? I don't even know. Okay, if I go to the coding Jesus one, order book HFT C++ implementation, right? So this guy,
My name is Ilya, and today I'd like to show you my C++ order book that I've created.
hmm
So I will break this into three sections. First, what an order book is really briefly. Then I will show you a demo of how mine works. And finally, I'll talk about how I designed the book from a programming perspective. So if you don't know, an order book is just a list of orders for any financial security. It lists buyers and sellers who are willing to buy and sell at different prices and quantities in the order book. Um, you can see up here, we in the red have all the asks, how much people are willing to sell for, or where this up to buy. So they're placed as a standing sell order, standing sell limit order. It is. We see that hash maps, one for the bids and one for the asks, and it holds hash maps of how is that this is a FIFO execution algo. So
Okay.
What's up, guys? Coding Jesus here. Guys, in today's video, first is a quantity used to fill both orders because you can't overfill an order.
Want to know if this is consistent. Buy or sell shares limit. Order. Okay. Order type. Order ID. Okay. This is the best resource I have, to be honest. And I just have to think about how to do this. Beautiful. silly little engine. Max heat, min heat. It is a record of outstanding limit orders maintained by the security specialist who works at the exchange. A limit order is a type of order to buy or sell a security at a specific price or better. A buy limit order is an order to buy the preset price or lower, while a sell limit order is an order to sell security or higher. Okay. Mm-hmm. All right, cool. And US as well. Um, okay, cool. All right, nobody's gonna hold my fucking hand here, so I need to do this by myself, which is fucking crazy. It is a leap a little bit. Uh, but I guess I just have to do it at some point, right? Shit, what happened? No, did I lose my fucking thing? I hope I didn't. I hope it just reset. But I think this is the best one that I can reference. Yeah, so yeah. Let's see. Let's see. All right, my profile. I went to uh caller methods project. Like these are all very poor projects, if I'm being honest. This is literally a notebook. Because it's all right. These are pretty bad projects though. This is private, good. Cross sex. This one I can. This one I can make private as well, if I'm being honest. Settings, make it private, please. Change to private. I want to make it private. Yeah, let's make it private. Destructive action? Yep, make it private. All right, great. Um, I bet I want to make private as well. Private. Pump and sniper. This can be private as well. But right now I think I only have four public, which is fine. And these four are fine. Um, hash table. So I'm thinking a priority queue in this sense. Define a few objects. So these are classes, I would assume, right? Binary tree of limit objects, sorted by limit price. So this would be like how you define a node or something like that, I believe, right? I think so. Okay. Okay, let's do this tomorrow. I think tomorrow I can definitely pour some time into this project. I have an idea of, I kind of have an idea of what to do because it says order is a list, right? Doubly linked list of order objects. Binary tree of limit objects sorted by limit price. So that would be like a min-max heap type of thing. Each of which is itself a doubly linked list of order objects. Okay, so there's the book object. And the book object is split into the buy tree and the sell tree. And there's the lowest sell and there's the highest buy. Some ideas are coming into my head. Not sure if they're correct though. Um, so I'm thinking the the book is the biggest object, right? The book is the biggest object. So let me share my iPad. Oh, oops, no, okay. It should come out, right? Okay, here. So I'm thinking the book is an object. It is an object that is like this. Limit star by tree, right? Limit star cell tree, right? Limit star lowest cell and limit star highest buy, right? If I'm not wrong. Yep. So this would be the book. And then it has a buy tree and then a sell tree. Right, and these are of type limits. So if you look in here, what is the buy tree? The buy tree is of limit. And then what limit is representing a single limit price. So buy tree is the root of a bunch of limit prices, right? It's a bunch of limit prices. Single limit price. So int price. And then int size. And then int total volume. And then limit parent. So it's the parent node, right? So this references this. So this link is formed. And then limit left child, right child, right? These are all pointers. So this node can reference this, can reference this, and can reference that. So right, okay, sure, makes sense. And then order, head order, and tail order. Okay, what the fuck is this? Right? We've never talked about this. The fuck is order, right? We've never talked about this order thing. What is going on here? So order. And this is every single limit price, right? So what is every single limit price? If you zoom into here, you go one level of abstraction down. Order is so every single limit price has a doubly linked list of order, correct? Right. The idea is to have a binary tree of limit objects, which means this binary tree, right, of limit objects. These are all limit objects. Every single node is a limit object, right? And these are all limit prices. So it's like one level of the book, right? And all of these are limbs. And each limb, within each limb, there will be a bunch of orders. And so each limit price in itself is a doubly linked list. It is a doubly linked list of what, you might ask? Of orders. Ah, okay. Makes a lot of sense. In itself, a doubly linked list of orders. So what is order like? Order is ID number, okay, a boolean of buy or sell, okay, to indicate if it's buy or sell, number of shares of the order, limit. What is limit? I'm not sure what that is. Entry time, event time. Order, this comes the linked list part. Next order, previous order, right? And then parent limit. Hmm. These ones, I don't really know what's going on. So the limit, event time, parent limit, I kind of understand because it's kind of like one limit price, let's say $100, and then it's a link of a bunch of orders, right? But you're giving all of these this link right here, if I'm not mistaken. Yeah, okay, yeah, that makes sense. Tracing out this gives a much better like overview of what's going on within the order book. I will take time to make this actually pretty so I actually understand what's going on. But yeah, I really need to go to the bathroom, so I'm gonna call it a day here. All right, peace, guys. See you tomorrow. 节目不能停。